it's talking about the gradient of a line. So if you have something at, say, that angle, and you look at how far it goes up compared to how far it goes across, like looking at this here, it's going up, we call that the rise, and the amount it goes across is called the run. If we compare the ratio of the rise over the run, we're getting what's called the gradient. Now the symbol for the gradient is m. Very often we put the gradient with an m, so it's the rise over run. So if this was like, say, 3 meters, for every 4 meters it goes across, then the actual gradient of that would be 3 on 4, or 0.75 as a fraction. Okay. If we look at one that maybe slopes a little bit higher, like that, and let's just say for every 2 centimeters it goes across, it goes 6 centimeters up, then the slope would be rise, which is 6, over the run. So it's rise on the run, so the rise is 6, and then you put that over the run, and the run is 2. So you end up with 3. So you have a gradient of 3. So gradient of 3 just means if ever I go, say I go from 1, I go up 3. Now when it's sloping that way, we say it's got a positive gradient. But when it slopes the other way, like that, like going downhill, let's say that was 6 meters and this was 8 meters, that there will have a negative slope on a number plane. So once you graph that on a number plane, it's like it's going downhill. So if you're modelling it using y equals x's, then the gradient of that line will be a negative. And the way to remember it's a negative is if you can make an n out of it, it will be a negative. But look at the positive one. You cannot make an n out of it, so it's back to front. So the actual gradient of this line would be 6 over 8, which is 3/4. But if you actually put it onto a number plane, it's really minus 3/4 because it has a negative slope and it's going downhill. So going on a number plane, going uphill is positive, going downhill is negative. Just here, you notice how it's flat? That would actually have a 0 gradient. This one has a positive gradient, this one has a negative gradient. So if you look on a number plane, you're looking at this one here, okay, and we're just going to make it go through some definite points here. So this one here, this here goes through 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 up, and that's 0. And we go 1, 2, 3. That's at minus 3. So we don't worry about the negative. We're more interested in the rise over the run. Okay. So the actual gradient would be the rise, which is 8, over the run, which was 3. So it's really 2 and 2/3 if you put it as an improper fraction. You can see it's a gradient of 1, like means, 1 to 1, okay? And it slopes at an angle of 45 degrees. You see this one here, you can see that its actual slope, it's a lot steeper than 45 degrees. And we were interested in one that's going down, that, like the run would be 1, 2, 3, 4, 5, 6, 7. The rise is 1, 2, 3, 4, 5, 6. So it has a negative slope, so the actual gradient is the rise over the run. So it's got to be the rise, which rhymes with the y's. So that's the y's over the run. So the run, which is that 6 there, which so that's the run, is the 7, the 7, not the 6. And that matches with the x's. So that's the run, and this is the rise. So the rise over the run would be minus 6 on 7 because it is going downhill. And for every one I go across, it's going down. Like it goes down, it keeps going down and down and down. So that's why it has a negative slope. Remember the way to remember too, you notice that if I make an N, that line sits right in the middle of the N, and so it's N for negative, and that's the way to remember. So let's just look at two more really quick ones. We're just going to look at the gradient from the diagram. Okay, we will put one that is going like that and one that is down here like that. Okay, there's x, y, x, y. Okay, so the rise, that's 3 there. So this is 3, and coming across here is 3. So the gradient is 3 over 3. So it's the rise on the run. And you notice it is negative. So the gradient there is negative 1 because 3 on 3 is 1. If we look at the next one, it's 2 across, 2 down. So the rise is actually the 2. This one, the 2 going down, that one. And the run is 2 across. So it's 2 for the rise and 2 for the run. So the gradient is 1, and it has a positive